infection was asymptomatic.
Okay, I'll come to the fact that the second one was asymptomatic in a moment, but we're saying, so basically, do we know where he caught the first infection and how different is it from where he caught the second?
It's not clear, and the virus wasn't very different between the two infections, but it was different enough that when you look at the genetic fingerprint, you can say that it's definitely a different virus. It's not the same one that's been lasted for 4 months.
So he was asymptomatic this time round from what you've just said. Was that the case previously?
No, he had symptoms the first time. The second time was asymptomatic. And I think that does kind of make sense, that his body does have some memory of the infection, maybe has some ability to prevent the disease, but he still had the virus and was shedding the virus.
Is this something that was expected in science, that it's possible that a reinfection could have happened, or could happen? Sorry?
Yeah, certainly it's possible. We've seen a lot of data already on immune responses to people who have COVID-19, and some people don't have a very strong immune response, others do. So we always knew there could be a possibility of some people having reinfections.
Yeah.
We're really glad, in this case, it's good news that the second infection was asymptomatic. I think
and
if
for the sake
anyone was
of
going to be affected,
for the sake of
have an asymptomatic infection.
Yeah, sorry, Ben, to interrupt you, but for the sake of our listeners, when you say immune response, what do you mean?
So we're looking at the antibodies in particular. So after an infection with a virus like this, your body will tend to develop antibodies that can then either protect you against being infected or at least reduce the impact of a second infection the second time around. This particular patient, the first time he got infected, after that, a month or two later, he did not have many antibodies.
I'm curious about what this means in terms of fighting this disease, especially for vaccine development. What do you deduce from it?
So we still don't know exactly how the vaccines are going to work, how well they're going to work, but if they work in a similar way to natural immunity, it suggests that maybe the virus is going to be with us for a longer time. Maybe it's going to turn into a seasonal infection like the flu that comes back from time to time. And I think that would mean, if that happens, that we will all need to get vaccinated, because the virus could still be circulating. If we've been vaccinated, maybe infections will be very mild or asymptomatic.
Right.
But if people have not been vaccinated, they could still get infected, and that would be a concern.
Will it mean that different areas, different regions might need different vaccines because of the different strains?
Not yet. So the virus has been gradually changing over the past 6 months, but there's no major changes in the virus, and vaccines should be able to provide protection against all the different variations. Of course, in the future, we don't know if suddenly something would change, but coronaviruses in general do not mutate that fast. They don't change that fast. So it's different to flu, where we need a new vaccine for flu every year. For this coronavirus, I don't think that would be the case, but maybe we need a regular boosting, maybe every 3 years or 5 years.
Ben Carlin, Division Head of Epidemiology and Biostatistics at Hong Kong University. Thank you.
And keep your science hat on, people, because we're going to talk more science now at 25 minutes past the hour. And this is a potential breakthrough for sufferers